Welcome to second webinar of our community, right? And if you haven't joined us in our first webinar, right, then let me introduce first what this community is meant for and what we are trying to do. Data AIML community is our own community, right? Here we are trying to share, learn, and grow together in data analytics field, especially in data science and the machine learning. And I'm one of the core member from the community. And today, due to some reason, Vikram is not here, who was supposed to be the moderator of this webinar. He's not here, so I'm handling that job. I don't have any idea how he had planned before, but I'll try to do as far as I know, and I'll give my best. Before starting, I'd like to give my brief short introduction. I'm Sisir Batrai, and right now I'm in Finland. I'm working as a data engineer in the ML platform in Aura, a ring health analytics company. And I'm actively working in data analytics, data science from 2012, something like that. And I started my career as a data scientist, and I have been doing the same thing till now. And I did my master's in machine learning and data mining from the Aalto University of Finland. Okay, and today we have Sushant, who will be presenting his research work regarding Devanagari language, and he will also try to do some demos and try to give his try to showcase his research to us. And let us welcome Sushant. Sushant, are you there?
Yeah, I'm here.
I think, yeah, now you can start, and stage is all yours. You can go ahead. You can share your screen and you can start.
Okay, yeah, is my screen visible?
Yes, we can see you.
Yeah, hello everyone. Namaste, I'm Shushant Pudasaini. Starting about me, I'm a computer engineering graduate. I have been working in the field of AI and data science for about 3 years now, and I'm more interested in the natural language processing domain. So let's talk about this event, what this event is about. We are focusing on applying natural language processing on Devanagari data. We will be discussing mainly about why this research field needs to be improved, what are the current state of the art results in this field, what direction should we be heading to for the improvement of this field, and what are the possible challenges that we might face. And at last, we will be conducting a short session on how can we train a masked language model on Devanagari data. So the prerequisites that the audience must have for this event to make sense is that the audience should have the basic knowledge of AI and machine learning and should be familiar with concepts in natural language processing like language model, word embeddings, and familiarity with Python is also great. So initially, let's discuss about why we should be researching and improving this field. NLP on high resource language like English is a well-researched and explored field. If we need to apply NLP on English textual data, there are lots of corpus, use pre-trained models like BOT and GPT that we can play with. However, there are no benchmark data sets, well-defined corpus, and pre-trained models that we can use to apply NLP techniques on Devanagari data. There is a Nepali national corpus, which contains about 3 GB of Nepali textual data and also has speech corpus. Similarly, we have Nepali corpus of about 1.8 GB of on-level textual data released by Oscar corpus. This corpus are fine starting point for learning to build pre-trained language models for Nepali language. However, to build language model capable of high-level natural language understanding, we require a huge amount of data. Another reason for why we should be focusing on this domain is that there are multiple research works and papers, research papers. the problem with we have even with so many research works and paper published is that there is no public benchmark data set, no publicly pre-trained model, and open source NLP based libraries and frameworks for developers for implementation or while developing NLP based applications on Devanagari data. So that's why we need to research and improve this field. Let's discuss about the application areas of this research. We can extend and apply research on several fields like text, speech, OSIA, and sign language. The research for one type of field can help for another field also. For instance, if we train a use pre-trained language model, that can also be used in speech domain for building a Nepali speech recognition model. We can build custom OSIA for identifying handwritten or printed Devanagari text. So these are the application areas. And let's discuss about how we should be dealing with this research field. So this is the overall procedure that we should be following for extending research in this field. We should initially we should build raw corpora and domain specific corpora for different techniques like web scraping, data annotation. After building such use corpora, we should be building corpus processing tools, which differs according to the corpus we have built. After such data collection, annotation, and processing, we will obtain training dataset and evaluation datasets for different NLP tasks, which we can release as public datasets. These public datasets which will be released can be the benchmarking dataset for new researchers who are trying to build new algorithms for Nepali data. After the release of this sort of benchmark datasets, all the researchers can develop high-performing and deployable NLP models on respective dataset. For instance, we can work on building an efficient Nepali named entity recognizer using the annotated NER data on Nepali text. To build this properly annotated NER data on Nepali text, we have to go through these steps: building raw corpora, building domain-specific corpora, and building corpus mining tools and processing tools, and building training. And after use level of annotation, we can build training and testing data sets. And after building such high-performing NLP models, so we can build developer tools like libraries and frameworks, which can be further used by other NLP developers to build NLP-based application for Nepali data. So let's discuss about the goals where are these NLP based applications, and as we can see from the slide, that we can build text generators applications like translation, chatbot, summarizers, inference engines like question answering engine, paraphrase detectors, grammar correctors. Okay, we know. We can also build input tools like keyboards, spell checkers. So after building this kind of products, let's discuss about where these research products fit and how they will be used for automation in several areas. As of now, Nepal government services is slowly moving toward digitization. The data in such government services are all in Devanagari Lipi. For applying automation for government services and bodies, we will be needing such research products. For instance, one of the services required to catch fake news spreading around social media. For building such fake news detector, we initially require NLU models that are capable of understanding Nepali text. The main approach that we should be following is now we should be building highly capable NLP models and release those NLP models and automation from such release. Automation in government services and social media platform, digital news, chat applications can be performed. Now let's talk about the approach. There are different research done in this field by different researchers, and many of them are following machine learning approach. And what I think is we should be adopting deep learning to solve our problems for this task. The approach goes this way. First, we will be building task independent use pre-trained models by performing pre-training on state-of-the-art architectures like transformer-based architectures. This model will be capable of basic natural language understanding and natural language generation. This pre-trained model can be further used in two ways. They can be directly applied for task independent fine tuning, or also used for feature extraction and further use the feature extracted for task independent training. Both approaches will give us task specific models like this. One step is feature extraction and task independent training, and another step is task independent fine tuning. So I will try to elaborate this process using a simple example. Let's suppose we are trying to build a Nepali sentiment analysis model. The major steps we should be following for this task is first, we should be doing data collection and preparation. Data pre-processing. For data pre-processing, we will be requiring Nepali tokenizers, Nepali lemmatizers, which we should build initially. After the pre-processing step, for the feature engineering part, especially for Nepali textual data, we can take these approaches: TF-IDF, pretend Nepali fastest embedding, custom Nepali word to vec embedding, Nepali bird embedding, and so this Nepali fast text embedding is like pre-trained and it is open source. But if we need to apply this, we need to build custom word to vec or doc to vec model on our data and apply this model for feature extraction. Similarly, another approach for appropriate feature extraction is the use of proper text embedding generated from the bot-based language model pre-trained on Nepali data. After that whole process, we should be building a classification engine, testing out different ML and DL algorithms. So in as a pipeline, this whole process is explained like this. We have a training pipeline and testing pipeline, and we have a text instance in our training part. We should convert this into a vector, and after converting this into a vector using train classifier, we will be building a model that separates positive and negative sentiment data, and the a decision whether the sentiment is positive or negative will be given by the decision function. So same in the test pipeline. We will be converting the text instance into a feature vector using these approaches that I discussed in previous slide. And after doing these steps on Nepali sentiment data, this data was like first I researched different sentiment data available on the internet. They were like poorly labeled. Then I decided to scrape the data from YouTube videos, Nepali sentiment data from YouTube videos, and manually annotate the data. So I prepared the data as with content like positive sentiment data about 8,340 and negative sentiment data about 8,200, and performing these steps in the data, I obtained results from different approaches. We can do TF-IDF for feature extraction and classification engine. I used SVC, and I've scored obtained from these different approaches were like this. Using the TF-IDF and support vector classifier, so the F score on the testing data was training and testing split was like 80-20, and the F score from TF-IDF and SVC was 0.61. However, when I used custom trained word to wake on the data and applied SVC as for the features for the word embeddings that resulted from this custom trained word to wake. App score improved like this 0.71. And similarly, I also tried to use the pretend bot-based Nepali model for feature extraction by concatenating the activation from the last four hidden layers of the model, and top of that, as building SVC model gave an impressive F score of 0.85. Further experimentations like fine-tuning on Nepali bot are yet to be done on the data. However, from this experiment, we can observe that we can obtain state-of-the-art results using such pre-trained deep learning-based language models for NLP tasks. If you want to take the feature extraction way, like taking adopting feature extraction for proper or generating Nepali embeddings for Nepali text embedding for Nepali text, you can use this library, open source by me. That's the this is the library to get embedding from for Nepali text from different architectures like custom word to wake, custom doc to wake, and custom mask language model trained on about 600 million Nepali sentences. So the uses of this library is given in the documentation provided in this GitHub link. I have like put the GitHub link here, and we can just use this library for proper feature extraction on Nepali textual for Nepali textual data. Similarly, you can also use pre-trained models that have been for getting proper Nepali embedding. There are like two approaches here. We can see that first task independent pre-training and feature extraction, and task independent training or task independent fine-tuning. For if you want to go this approach, this approach for training proper NLP models on Devanagari data, then you would have to use this library Nepali embedding first initially for feature extraction task, and on top of that you can train any maybe classification models or text generator models like this. And if you want to go with this approach, task independent fine tuning, you can use this pre-trained models, pre-trained models like Nepali bot and Distill GPT to fine-tuned Nepali GPT. And, this Nepali bot is a mask language model written on bot architecture specifically for natural language understanding task on Nepali language. Like the previous sentiment analysis example, so that's a natural language understanding task. And if you want to fine-tune a sentiment analysis model using bot architecture, you can use this sort of pre-trained model to fine-tune the sentiment analysis model and get proper result. So this mask language modeling is the task of identifying or filling a mask place in textual data by using the tokens provided in the other tokens in the sentences, as you can see here from the slide. This is a fill mask pipeline in the Hugging Face platform, and the input is like this: Ramle, Bhat, and mask. And so the task is to predict the word that would be appropriate for this mask place. So when we compute this, the predicted words are like this: khana, khae, pakauna, Oka is like this. So, this some model, this mask language model is pretty good, and it's been trained on about 5-6 CV of Nepali data, unstructured data that has been collected by scraping online news platforms. And if you want to fine tune other NLP downstream tasks like sentiment analysis, name entity recognition, question answering model, or Nepali news summarizer model like this, then you can just use this model by using the script written here like this. You can first import the auto tokenizer and auto model for masked LM, and get the tokenizer from Hugging Face platform like this auto tokenizer from pretrained, and auto tokenizer for mask LM from pretrained, and you can use this for further fine tuning. Similarly, there is another Nepali causal language model. Sorry, there is another Nepali causal language model. Causal language modeling is the task of identifying similar masked place word using both sides text in the sentence, and this causal language model is pretend using the distilled GPT-2 architecture. So for language for natural language generation task, you can use this, and on Nepali text you can use this, and for natural language understanding task on Nepali text you can use this model. So while dealing with low resource language like Nepali, and building use language models and other NLP models, there are like different challenges which we face in terms of training data, in terms of evaluation, and in terms of deployment. So in terms of training data, the low availability of raw and domain specific data is one of the problem. The data size is another problem. Annotation skills, like there are no properly annotated data, benchmarking data for a task like sentiment analysis, name entity recognition, lemmatization, this kind of things. And annotation quality is also another problem, like I previously mentioned. While researching Nepali sentiment data, I found poorly annotated data online and tried on that, and so that was not good, and I like built another sentiment data by annotating the data manually. So in terms of deployment, there are like some different challenges. The model size is one of the challenges. This language models and use deep learning based models on transformer architecture. So model size is used. Due to this, creates problem in deployment and inference time. Like previous session by Vivek was mainly focused on compressing such use deep learning based models for proper inference time, and reducing model size and this kind of thing. So we face those challenges in this domain also. And building development tools and maintenance are also other challenges in the deployment part. And in the evaluation part, like quality judgments and feedback for improvement, and like proper evaluation metrics for proper NLP tasks are also other scalability challenges. And the main challenge is that effort and cost increase as languages increase, like this. Effort and cost increases as the amount of data also increases. So what we can do is adopt these possible steps to improve this research field. We can build a collaboration among developers and NLP researchers to work in this field. Like previously, I mentioned that there are no benchmarking datasets, benchmarking corpus, benchmark pretrained models to work in this field. And we can like prepare label dataset for downstream tasks like POS tagging and NER as benchmark datasets. Using this benchmark datasets, we can develop benchmark results for NLP tasks in such datasets. And after we develop different NLP models, use language models like this on the benchmark datasets, we can develop NLP framework for Nepali language so that developers can use this framework for any NLP task related to Nepali language. So for instance, if we need to apply NLP techniques for English text, we have different open source NLP libraries and frameworks like Spacey, NLTK, Gensim. There are like many pre-trained models there, and pre-processing tools are also great in those frameworks. But if we want to do the same thing for Devanagari data, we cannot use those English pre-trained models and English pre-processing techniques for developing such NLP applications on Nepali data. Suppose if we want to do lemmatization or if we want to do POS tagging, we can use a specific framework to find the appropriate part of speech tags in English text. But for Nepali text, we need to build our own. So after this research, with this collaboration and research in this field, we can finally develop NLP framework for Nepali language so that they can be this framework can be used further by other researchers. So yeah, this is the talk, and I will be giving a short session on how to train a mask language model with Nepali data using Hugging Face Transformer Trainer API. So there are like
Sushant, would you like to take question from your first presentation now, or you like to take at the end of the second session? How do you want to go?
Anything would be good. Okay, I would like to take the questions.
Yeah, because the now we can go through more theoretical question, and at the end we can go more practical question.
Yeah.
Here, question is from Sulabh Kargi. Okay. What kind of biases can we see in this domain, this in NLP domain? I think you want to mainly emphasize in Nepali language, right? How do you deal with it?
So the bias we can see on this Nepali language domain is that there are no proper metrics and benchmarks for doing NLP task on such Nepali textual data. Yeah, that's the answer.
Okay. And another question is from my side, right? Do you have any plan or any proposal that how, as a community member, we can contribute to label the data and make our NLP dataset more rich? Do you have any plan or any proposal for that?
Yeah, I do have plan for that. From this community, like who are interested in performing research in this field, like I is explained here, who are interested in performing research in this field, we can like build a separate group, and we can first so like we should be following these procedures which I explained previously, like building raw corpus and corpus mining tools. And from that, we should be building training and evaluation data sets. And we should be on further that we will be building NLP models, and finally a framework which would possibly be a Python-based framework. And on using that framework, we can build NLP applications for Nepali dataset.
Okay, there is another question from Milan. Gautam, would you mind telling us the amount of the data used to pretend the model and what were the sources of it?
Yeah, I think I mentioned in the slide also. The mainly the data was collected from Nepali news platform like Ikantipul and this kind of sites, scraping this kind of sites. And what we need for language model pre-training is we do not need annotated data. We need unlabeled data as like this, like in this format. Let me open this. We just need this kind of unlabeled textual data. And what I did was script Nepali news sites and created a data set of size about 4.6 GB and use this data set for language model retraining.
Okay, and I think we'll take the last question. It is from Sushant Shah, and I assume that it has been already covered by Sushant. Let me ask you again. Can you talk more about how you collect the data and what were the obstacles? Just in the short 1 minute, because we need to move to another session now. Can you discuss what are the obstacles we have faced? One or two.
The main obstacle is like while scraping the data, so we might also the scraping bots might also scrape English textual data or other language textual data, and we need to filter those other language textual data. And in the cleaning process, there are like different obstacles.
Okay. And let us move to the second session, right? Sushila, I'll take your question after the second session. Let us wait for that. Tokenization and those sort of things. Sushant might cover that in this second session. Okay. Sushant, you can go for the second session.
Okay. So this session is about training a mask language model with Nepali data using Hugging Face Transformer Trainer API. And there are like different ways of training for using transformer based architecture. There are like two approaches, either pre-training or fine-tuning. And for developing mask language model, we should be doing pre-training on the bot transformer based architecture. There are like different ways how we can train such a mask language model or perform the pre-training of such mask language model. There is we can also do from this repo. Sorry. So we can, this is the repo of the board-based architecture, board-based models published by Google Research and open source by Google Research. And here are the steps of pre-training and fine-tuning. And here are the scripts for pre-training and fine-tuning such NLP-based models on board-based architectures. Like here is the documentation of fine-tuning with board and using bot to like for feature extraction, this kind of things. And here is the script for pre-training with bot. We can use this scripts that is research that is open source by this for doing pre-training. We need scripts like create pre-training data and run pre-training.py. And other ways like using other wrappers. So all other open source frameworks are like wrappers built around this script for pre-training or fine-tuning steps. Like we have wrappers like simple transformers and transformers. This Hugging Face is an open source company which like facilitates this training and testing step, training of transformer based language models on different data sets. There are like different data sets available, and we can upload our model and use other models from this, and there are like logging face spaces to try out new things. What we'll be doing is we will be um, learning to pretrain a masked language model using Hugging Face Trainer API. There is like documentation here. So this we should be following this documentation for different steps, like pre-training and fine-tuning, and we can do everything from this Hugging Face Trainer API. And what we will be doing is using this API, we will be training mask language model as this. So I think we have shared this collab link, and like first we should be installing transformers library like this. And first what we should be doing is creating custom tokenizer to build the pretend language model on Nepali data set. We have data set just built. I have just used few small size data for the demonstration here, but we can use use data sets for creating such custom tokenizer. And for training custom WordPress tokenizer, this is also in this documentation, but I will go through the script shortly. As first we have to import tokenizers library and pyters, and this from this tokenizers library we can call bot WordPress tokenizer and pass parameters like unknown token, separate token, CLS token. These tokens are defined according to the transformer based architecture on which we are performing pre-training, and other parameters like clean text, lowercase, WordPress prefix like this. And we can provide multiple files in this list. So we should provide the path of the textual data, and we should pass the vocab size. So vocab size here is the vocabulary size of the tokenizer, like how many unique tokens we should be creating from the textual data that we are providing. And like minimum frequency is to be considered in the vocab. What is the minimum frequency of the token? And like special tokens like padding, unknown token, CLS, mask, and SCP are also added like this. And after training this model from this PWPT instance, which we built from the tokenizers.bot WordPress tokenizer class, we can also perform save model like this. So to save the model, we are giving some folder location here, bot Nepali tokenizer. So I'm making the directory here, and after doing this, so after training and saving, the training won't take much time because it's on few data set, and training tokenizer won't take so much time. And we created a vocab.txt for the bot WordPress tokenizer like this. And so using this tokenizer, custom Nepali WordPress bot WordPress tokenizer, we will be now training language model using Hugging Face Trainer API. So all this Like these things should be imported from transformers library like bot tokenizer, bot config, bot for mask LM. What we are doing is mask language modeling here. So we should be using bot for mask LM and data collateral for language modeling and trainer. That is the trainer API that we are using of transformer library and training argument and reading line by line text data set and like this. And toss is like if we want to use this transformers library, we can use using both PyTorch and TensorFlow, but I'm using PyTorch as the backend language for this trainer API. And here we are giving the vocab file path, which is this bot Nepali tokenizer and vocab.txt. And from this vocab file, we are again loading the tokenizer. This tokenizer instance and is the tokenizer that we built previously and saved. And again, we loaded the tokenizer here. So vocab size 30522 and total epoch is the number of iterations we want to pass while pre-training. And we can like define a evaluation data set and training data set. So data set file path so we I have already loaded the Nepali news 1.txt and Nepali news eval.txt, which is like this: Nepali news 1.txt here, and this is for training, and Nepali news eval.txt, this is for testing. So we can generate evaluation metrics using this. And after this, this is for saving the mask language model, and I'm defining the pathway to save it, and output directory. Like while training such language model, we should be using checkpoints, because if the training such pre-training such language models on used textual data might take several days depending on the device which we are using for training. And so we should be saving the checkpoints for in the training process, so that we can resume from that checkpoints while we face us break issue. And this is the configuration which we pass into the bot config, which we import from here. Like what is the vocab size, what is the hidden layer size, what is the number of hidden layers, and what is the number of attention heads, and what is the max position embeddings. These parameters for bot based transfer bot based models, like how many number of attention heads you want to use for this pre-training task like this. And we pass this config bot config instance to bot for mask language model. And we this we send this model to device. This is used if we are using GPU for pre-training. So let me check. No, I'm not using GPU or anything for pre-training, because this is on very small amount of data, and this can be performed without using GPU also. So, we should be building a data collateral for language modeling based on this tokenizer, and passing arguments like MLM is equal to true and MLM probability is equal to 0.15 or any argument, that you can try out other things also here. And we are creating data set and eval data set by passing data set file path and eval data set file path here. And I'm filling the number of lines in the data set. And training arguments. Training arguments are those configs or parameters that we should be using for while training pre-trained language models. This bot config is what parameters we want to use for the bot architecture. And this parameter is for what this training asks is for what parameters while to be used while pre-training of the language models. So parameters are like this: specifying output directory, override output directory is equal true. That means while saving the checkpoints, so do we want to overwrite the checkpoints or not? And number of training epochs, per device trained batch size. This is like how many data instance do we want to use while training such language models. And per device eval batch size. Save steps is equal to 10,000 means while saving the checkpoints, after how many steps do we want to save another checkpoints, like this kind of thing. And do eval is equal to is run evaluation, do training is equal to means run training, and evaluation strategy means evaluate after certain steps. And another is finally we build the trainer instance of the trainer API from transformers, and we should pass the model here, we should pass the training arguments here, we should pass the data collateral which we built previously, and we should pass the training data set here and evaluation data set in this trainer object. And finally we can call this trainer.train and train the language model like this. Okay. Okay. I forgot to run this. And after training we can run evaluation like this. So evaluation language model are mainly evaluated in terms of perplexity. So we cannot get the perplexity here, like it is under training. It is training for like 5 epochs. After this session I will also share the collab link, and so you all can try training this language model and using this model to generate appropriate language model on the data collected. Like checkpoints are saved like this here. Checkpoints is saved like this. We can we can use this checkpoints if our training process is halt, and resume from that checkpoint if we want to train more. And yeah, evaluation. After running evaluation, if we see the eval results, eval loss in terms of perplexity, this is like 285. This perplexity score is very low. So it's like higher the perplexity, and that is the language model is very poor. So perplexity should be very low in terms of obtaining proper language model. And we can after training this model, we can use the model from pipeline API provided by the transformers like this. So our task is fill mask, that is mask language modeling, and we need to provide a model and tokenizer like this. And now this so we need to pass here our data as like this. and we can just use this model. It depends on, there are like several pipelines. So timilai kosto, and here we apply tokenizer.mask token, and it tries to predict another token, here it is predicting kho, here it is predicting punavidam, no, like this, law, like this, which is very poor result, because this model is like trained on very low amount of data. So you can try like this. You can try this model, which is trained on use data, and the model files is also very large. This one file is about 418 MB, and yeah, this model and another distill GPT fine-tune model. Okay, let me this one. You can test this models. This is causal language modeling, and the previous one is for mask language modeling. So this one is for mask language modeling. Yeah, that's it. Like how we can train a mask language model and use it. Now this mask language model can be used further for other fine-tuning task, as I mentioned previously, here. Let me show you. This on this sentiment analysis task also, this language model was used for generating proper for feature extraction step, for generating proper text embedding for Devanagari text, and SPC was applied further in it, and so very good result on Nepali sentiment so was performed. So there are like two steps, as I explained here. After we create task independent pre-trained models like this, which I explained in this session, we can adopt two steps, which is task independent fine tuning, so which can be done using this pre-trained language models. There is like there's proper documentation here, like how to fine-tune a model for common downstream tasks like this. Here is example like performing classification on IMDb dataset, performing name entity recognition on CUNLL dataset, and performing square question answering fine tuning on square dataset. Here, dataset is loaded here, and fine tuning with trainer API while using this. Like this, we can fine tune it on our here while doing fine tuning. Tokenizer is equal to auto tokenizer dot from pretend. This is distill bot based on case is being used in this for this data set, because this is English data set, and bot based on case model will give proper result while using while fine tuning for English data. But for Nepali data like sentiment analysis or question answering data, summarization data, we can use this sort of pre-trained models like this, same like this, which will give proper results on while doing fine tuning also, while doing this task independent fine tuning also, or while adopting this feature extraction and further task independent training also.
I think, Susan, now we need to wrap up. We need to go through the questions posted by the members, right? Thank you.
Okay.
Yeah, thank you, Susan, for the wonderful presentation and putting your research and your ideas how we can leverage community resources or people like us to go and solve the localized problem in Nepali text, right? It was very good and interactive session for me, and seems like your research will be like a starting point for so many researchers out there in our universities, colleges, or the professional one. Now as I mentioned, that now we'll go through the questions posted by the members, right? And please free to add your question in the chat, right? I'll be taking them one by one and Susan will be replying them. Yes, there was one question regarding Susil has asked something regarding the tokenization, right? Could you go through what might be the best way to tokenize Nepali text or tokenization specifically? He's looking for how we can go and tokenize the words.
So this tokenization also depends upon which transformer architecture that you are trying to pretend on. If we want to pretend on word-based architecture, we should be developing word-based tokenization. And if we want to train pretend language models on GPT architecture, we should be going with other subword tokenization algorithms. So yeah, this basically depends on the transformer architecture that we are using for pre-training.
Okay, thank you. Now, next question is from Yugon, right? He has mentioned that while loading models from the Hugging Face, there is option of using float 16 and float 32, right? And he would like to know what might be the difference between these two.
I'm also not sure on this one. We can do it from.
Yes, he has mentioned FP16 or FP32. I assume that is float 16 and float
14.16 or 14. This might be the this is basically loading model, means basically loading the weights that has been is resulted while pre-training, right? So this might be whether we want to load the model weights in float 16, FP16 or FP32. FP16 would model maybe like lighter, and inference time would be very less, but FP32 model might be heavier.
Yeah, and I don't see any question from our member. I have few questions regarding the dataset. Okay, there is one question from Sulabh. Can a model trained on the news portal text corpus generalize for the real world scenario?
Yeah, so basically, this cannot be achieved for a real world scenario. We can build other data set. So this data set that I used was from news portal data set. For a generalized model, we can use generalized data set like wiki data set or this or book data set, book corpus like this.
Yeah, here I would like to add more, right? For Sulabh, right? You need to be very specific. What is your real world scenario, right? For me, the real world scenario might be the health, right? For Sushant, it might be the finance, right? For someone, it might be the education, right? And among those three domains, the terminology or the tokens or word we use might start to differ, right? And at that time, those might not be covered by the news or those sort of things. However, I think we can use the embeddings and everything as a pretend weights and the starting point, but you need to go and you need to fine tune your model based on the data what you have collected from your own domain. It is very difficult to generalize everything in machine learning.
Sir, my question is kind of difficult, so I would like to ask myself, as we know, a bot can take 512 words at a time to be trained. Suppose there are two articles, one having length of 150 words and another having length of 700 words. So in this case, are we going to pad the first article, which has a 150 words, to make it up to 512, or are we going to start the second article right after the first article, that is from 151 word onward? What is the procedure?
So for this, so like a bot based model accepts 512 tokens at masks, and after those tokens, like other are truncated. But this is for other fine tuning tasks like sentiment analysis and this kind of things. This is not fine tuning. This is pre-training.
Yes, my question is for pre-training. Yes, if I have two news articles, one is smaller and one is larger, we can't merge two of them because two of them are independent. And this 512 word, I think, should be from a single article, so that the bot can learn it from a single article only, isn't it?
Like you are training two language model for two different articles.
No, I'm training this. I'm training news portal, as you have said, and but there are some really big problems. Some of the articles are very short, and some of them are very large.
Yeah.
And the main context or the main context of मैले चाहिँ नेपालीमा भन्न चाहे, सपोज मसँग चाहिँ 1000 वर्ड छ भनेर भनौँ है, अनि त्यो 1000 वर्डको सपोज कुनै आर्टिकल छ क्रिकेटको बारेमा, कोहलीको बारेमा छ भने, अब मैले सुरुको 512 वटा वर्ड लिए त्यो आर्टिकल 1000 बाट, अनि ट्रेन गरेँ, अनि ट्रेन गरिसकेपछि बच्यो त्यसको अराउन्ड 488 वटा वर्ड बच्यो। अब 488 वटा वर्ड मध्येमा त अगाडिको त मुख्य कन्टेक्स्ट त गइसक्यो ट्रेन हुन, पछि त त्यो पछिले त 512 वटा वर्ड हेर्न पाएन नि त, पछि त जम्मा 488 मात्र वर्ड हेर्न पायो, तर त त्यो आर्टिकल त कम्प्लिट हेर्न नि त वर्डले त।
तर यसमा त प्रिट्रेनिङ गर्दाखेरि 512 टोकन के दिनुपर्छ भन्ने छैन नि त। त्यो अघि हामीले हेरेको थियौँ नि, त्यहाँ लाइन बाई लाइन टेक्स्ट डेटा सेट बनाउँदाखेरि डेटा सेट फाइल पाथहरू दिइन्छ, अनि डेटा सेट फाइल पाथहरू चाहिँ लिस्ट अफ स्ट्रिङ हुन्छ। स्ट्रिङमा चाहिँ त्यो होल डिफ्रेन्ट आर्टिकल, अब तिमीले कलेक्ट गर्यौ, एउटा न्युज कलेक्ट गर्यौ .txt, अर्को न्युज कलेक्ट गर्यौ .txt, त्यो सबै डेटाहरूको पाथ दिने हो नि त।
Is that question who asked that question?
Sir, Milan Gautam.
Milan, I assume that I think you are right now working on Q&A.
Yeah,
right?
yeah.
Yes, right. You are working on Q&A and you are trying to get this answer. How can you pass the context which is greater than 500 to them? That was your question.
Yeah,
and you were trying to project that in another
question answering Q&A is like fine-tuning task, not pre-training task. So we can apply, you can solve your problem like this. Suppose you are performing question answering and the context, there is like for question answering, context, question, answers, right? So if context size is very used, how are we passing that context size in the inference engine, right?
Yeah, that might be the first question.
Yeah, that is your question. So there are also like several solutions for this task. One is like making chunk of that whole context and passing that chunk by performing adding like if this is for sentiment analysis, send different chunk to sentiment analysis model, generate prediction like and get the average prediction from different chunks. Those we can pass 512 tokens in bot-based models, and our data on which sentiment analysis is to be done is like of 1000 tokens. Then what we do is create two chunks. first of 512 tokens and another of after that 512 tokens, and generate prediction for both chunks using that as using same model. And if like there will be for initial chunk there will be like positive score this, negative score this, another chunk positive score this, negative score this, then we can use get
average in the end.
Average in the end for both songs. So this similar concept can also be applied for question answering.
Okay, now I'll add more on this answer. Is that Monish, right?
No, sir, Milan Gautam.
Okay, Milan. The thing in machine learning you need to understand is that it's art, right? You need to go and do a lot of hit and try. There is no something called it is the bullet solution. It will go and solve all the problem, right? And one of the approach what Sushant had told could be applied, right? And second approach is you need to define what is acceptance criteria for your project. How much information you can lose to go and adapt those sort of constraints, right? And one approach can be you can use TF-IDF, right? And based on that score, you can remove the tokens which doesn't make sense, and you can try to excuse the length of the sentence itself. That is another approach, right? But the thing is that you need to go and try different approach. You need to benchmark, and you need to use the one which will go and solve the problem. There is nothing called this will go and solve the problem.
Okay, sir. There's not such hard and fast rule.
There is no such an hard and fast rule. However, you can find few papers, research paper, right, where they have defined this Q&A based on hierarchy tree, right, where you can pass different context by breaking, right, and those contexts in the previous approach, right, the problem will be that if the first and the second context, right, had some sort of relation, right, then it doesn't hold that relation because it will act as an independent thing, and you are trying to bind the answer, right? But there are some models, right? You can find the paper easily where they have architecture, they have defined the architecture in such a way, right? It will start to act at the hierarchy. And what does it do? It will break the text, right? However, it will try to preserve the relationship or the information between those two chunks also. There are those sort of Q&A models architecture you can easily find, and they have already open source those code in GitHub also.
Thank you, sir. Thank you.
Yeah. And another thing, please try to make sure that if you have those sort of concern or those sort of questions, make use of Ask question or something like that channel in our Slack, right? So that we can reach out or we can reply regarding your problem, right? And we can help you. And another, do we have any question? I don't think that there is any question. I have one question for Sushant. It's very good, right? You create your own bot to go and crawl the text, and we have created this pretend thing, right? And my only one concern is regarding the legality of the things, right? Because newspaper own their content, right? Do in Nepal, do they have this sort of policy, or do they have this any sort of legal thing, right, where the newspaper own their content and we cannot use those content for making any sort of pretend model or models or something like that? Because if we are scaling, we need to think about the legality also.
Yeah.
Because we don't own that content, right? Those newspaper own that content, but we are trying, we are creating the bot, we are crawling that, right, and we are trying to create the pretend model, and we are claiming that is our, but the data is not our data, is owned by someone else.
Yeah, honestly, I haven't think about it.
Yeah, I think we need to look over those sort of things also, right? Because now we're trying to leverage and we're trying to tag more data, right? I think that might be the another thing we need to immediately go and see, and we need to go and get the answer. And I think after that, as a community, right, as myself, I'm so eager to help you to get this data done and just provide data to the community. If there is any question, anybody, just you can unmute yourself and you can ask the question if you have any. Seems like we don't have any questions. Please fill the feedback form. It will help us to improve this presentation and the talk. As based on last week feedback, we realized that the session need to be a bit interactive. So we asked Sushant to make it a bit interactive, and he has done. And we try to provide collab link before the presentation, right? And if you haven't, if you don't have link right now, you can find either in chat or you can go and get from Slack, right? So we need your feedback to improve this session. And I think we are done over here. Thank you everyone for being here and giving your more than 1 hour weekends evening, right? Thank you. Have a nice day or nice weekdays ahead.
Yeah.
Bye.